The 2002 National Electrical Code, or NEC, and the 2005 NEC have discrepancies in Table 5 and Annex C, specifically concerning conductor fill calculations. In the 2002 NEC, the cross-sectional area for type THW number 10 wire is incorrectly listed. The 2002 errata sheet corrected this error by deleting the incorrect value. However, the 2005 NEC reverted the change, incorrectly listing the cross-sectional area for type THW number 10 wire again. The discrepancy in Annex C between the 2002 and 2005 NEC arises from the misprinted Table 5 value for type THW number 10 wire. In the 2002 NEC, the incorrect value in Table 5 led to an incorrect calculation of allowable fill in Annex C, specifically the example for 1-inch electrical metallic tubing, or IMT, in 2002 Annex C allowed 14 conductors, based on the incorrect value for type THW number 10 wire. When the 2005 NEC corrected the Table 5 value, it should have also corrected the Annex C calculations to reflect the new value. However, the 2005 Annex C erroneously retained the incorrect calculation based on the old, wrong value. As a result, the 2005 Annex C calculation for 1-inch EMT now only allows 10 conductors, which is incorrect. These discrepancies between the 2002 and 2005 NEC appear to be due to a reversal of errors from the respective errata sheets. The 2002 errata sheet corrected the misprinted Table 5 value for type THW number 10 wire, but the 2005 errata sheet reverted the correction. This resulted in an incorrect Table 5 value in the 2005 NEC, which in turn led to an incorrect calculation of allowable fill in Annex C. It is important to note that the cross-sectional area of type THW number 10 conductors is correct as indicated in the 2002 NEC errata sheet. The incorrect value in the 2005 NEC should not be used for calculations. When working with electrical codes, it is crucial to understand how these tables and annexes interact to ensure safe and compliant installations. Errata sheets play a vital role in clarifying and correcting errors in published codes, so always refer to the latest versions and updates. Now let's delve deeper into the specifics of Table 5 and Annex C. Table 5 in the NEC provides dimensions and cross-sectional areas of conductors. These values are essential for calculating conduit fill, which determines the maximum number of conductors that can be safely installed in a specific size of conduit or tubing. The cross-sectional area of a conductor, typically measured in square inches, is a critical factor in these calculations. The correct cross-sectional area ensures that the conduit is not overfilled, which can lead to overheating and potential fire hazards. Annex C of the NEC provides examples and guidelines for calculating conduit fill. These examples demonstrate how to use the conductor dimensions from Table 5 to determine the allowable number of conductors in various conduit types and sizes. The calculations involve considering the total cross-sectional area of the conductors and comparing it to the allowable fill percentage for the specific conduit type. Different types of conduits, such as EMT, rigid metal conduit, or RMC, and PVC conduit, have different fill capacities. Understanding these differences is essential for selecting the appropriate conduit size for a given installation. The NEC specifies fill percentages based on the number of conductors in the conduit. For example, a conduit with 2 or fewer conductors has a different allowable fill percentage than a conduit with 3 or more conductors. These fill percentages are designed to ensure adequate space for heat dissipation and to prevent damage to the conductors during installation and operation. When discrepancies arise between different editions of the NEC, it is crucial to identify and understand the source of the error. In the case of the 2002 and 2005 editions, the error originated from a misprint in Table 5, which was later corrected by an errata sheet. However, the correction was not consistently applied in subsequent editions, leading to further confusion. Errata sheets are official documents that identify and correct errors in published codes and standards. These sheets are typically issued by the organization responsible for publishing the code, such as the National Fire Protection Association, or NFPA, which publishes the NEC. Errata sheets are an essential resource for electrical professionals as they provide up-to-date information on corrections and clarifications to the code. It is important to consult errata sheets whenever working with the code or standard to ensure that you are using the most accurate and up-to-date information. In the case of the NEC, errata sheets can be found on the NFPA website. These sheets are typically organized by code edition and include a list of corrections and clarifications to the code text. When reviewing errata sheets, it is important to pay close attention to the specific sections and tables that are affected by the corrections. The errata sheet will typically provide a clear explanation of the error and the corrected text or value. In the case of the 2002 NEC errata sheet, the correction involved deleting the incorrect value for the cross-sectional area of type THW number 10 wire in Table 5. This correction was intended to ensure that the correct value was used for conduit fill calculations. However, the 2005 NEC inadvertently reverted this correction, leading to the discrepancies discussed earlier. When performing conduit fill calculations, it is essential to use the correct conductor dimensions from Table 5. Using incorrect values can lead to overfilled conduits, which can have serious consequences. Overfilled conduits can generate excessive heat, which can damage the conductors and insulation. This can lead to short circuits, ground faults, and even fires. In addition to the risk of overheating, overfilled conduits can also make it difficult to pull conductors through the conduit. This can damage the conductors and increase the risk of insulation damage. It is also important to consider the derating factors that may apply to conductors in a conduit. Derating factors are adjustments to the allowable ampacity of a conductor based on the number of conductors in a conduit and the ambient temperature. When multiple conductors are installed in a conduit, the heat generated by each conductor can raise the temperature of the other conductors. This can reduce the ampacity of the conductors and increase the risk of overheating. The NEC provides tables and guidelines for applying derating factors to conductors in a conduit. These derating factors are based on the number of conductors in the conduit, the ambient temperature, and the type of insulation used on the conductors. It is important to consult these tables and guidelines to ensure that the conductors are properly derated and that the conduit is not overfilled. In addition to conduit fill calculations, Annex C of the NEC also provides examples and guidelines for other types of electrical calculations. These examples cover a wide range of topics, including voltage drop calculations, short circuit calculations, and grounding calculations. The examples in Annex C are intended to provide practical guidance on how to apply the NEC to real-world situations. These examples are often used by electrical professionals as a starting point for their own calculations. When using the examples in Annex C, it is important to understand the assumptions and limitations of the examples. The examples are typically based on specific scenarios and may not be directly applicable to all situations. It is also important to verify the results of the examples using your own calculations and engineering judgment. In addition to the examples in Annex C, the NEC also includes a number of other annexes that provide supplemental information and guidance. These annexes cover a wide range of topics, including wiring methods, equipment installation, and special occupancies. The annexes are not part of the enforceable requirements of the NEC, but they can be a valuable resource for electrical professionals. When using the annexes, it is important to understand that they are intended to provide guidance and clarification, not to establish new requirements. The enforceable requirements of the NEC are found in the main body of the code, not in the annexes. In summary, the discrepancies between the 2002 and 2005 NEC regarding Table 5 and Annex C highlight the importance of using accurate and up-to-date information when performing electrical calculations. Errata sheets are an essential resource for identifying and correcting errors in published codes and standards. When performing conduit fill calculations, it is important to use the correct conductor dimensions from Table 5 and to consider the derating factors that may apply to conductors in a conduit. Annex C of the NEC provides examples and guidelines for conduit fill calculations and other types of electrical calculations. These examples can be a valuable resource for electrical professionals, but it is important to understand the assumptions and limitations of the examples. By using accurate information and following the guidelines in the NEC, electrical professionals can ensure safe and compliant electrical installations. Furthermore, understanding the historical context of code changes, such as the errata corrections in the 2002 NEC and their subsequent reversal in the 2005 NEC, is essential for avoiding potential errors in design and installation. This knowledge helps in critically evaluating the information presented in different code editions and applying the most appropriate and accurate data for specific applications. The case of the THW number 10 wire cross-sectional area discrepancy serves as a reminder of the importance of double-checking values in calculations, especially when working with older code editions. Always cross-reference with errata sheets and consider the potential impact of seemingly small errors on overall system safety and performance. The NEC is a complex and evolving document, and staying up to date with the latest changes and interpretations is crucial for all electrical professionals. Continuous learning and attention to detail are essential for ensuring the safety and reliability of electrical systems. The discussion of Table 5 and Annex C discrepancies also underscores the significance of understanding the interrelationship between different sections of the NEC. Changes in one section of the code can have cascading effects on other sections, and it is important to be aware of these connections. For example, a change in the allowable opacity of a conductor can affect the required size of the overcurrent protection device, which in turn can affect the size of the conduit needed to accommodate the conductors. Understanding these interdependencies is essential for designing and installing electrical systems that meet the requirements of the NEC. In addition to the specific example of Table 5 and Annex C, there are many other areas of the NEC where discrepancies and errors can occur. It is important to be vigilant in identifying and reporting these errors to the appropriate authorities. The NFBA has a process for submitting proposals to amend the NEC, and electrical professionals are encouraged to participate in this process. By working together to identify and correct errors in the NEC, we can ensure that the code remains a reliable and effective tool for protecting people and property from electrical hazards. Finally, it is important to remember that the NEC is not a substitute for sound engineering judgment. The NEC provides minimum requirements for electrical installations, but it is up to the electrical professional to determine the best way to apply these requirements to a specific situation. The NEC should be used as a guide, but it should not be followed blindly. Electrical professionals should always consider the specific circumstances of each installation and use their knowledge and experience to make informed decisions. In conclusion, the discrepancies between the 2002 and 2005 NEC regarding Table 5 and Annex C provide a valuable lesson in the importance of accuracy, attention to detail, and continuous learning. By understanding the historical context of code changes, staying up to date with the latest errata sheets, and exercising sound engineering judgment, electrical professionals can ensure the safety and reliability of electrical systems. The NEC is a complex and evolving document, but by working together, we can make it an even more effective tool for protecting people and property from electrical hazards. It's also worth noting that the NEC undergoes revisions every 3 years, so staying current with the latest edition is critical. Each new edition incorporates updates and changes based on new technologies, industry best practices, and feedback from electrical professionals. Familiarizing yourself with the changes in each edition helps ensure that your work complies with the most current safety standards. These revisions often address emerging issues and clarify existing requirements, making the code more user-friendly and effective. Additionally, continuing education courses and professional development opportunities can help electrical professionals stay abreast of the latest developments in the field. These resources provide valuable insights into code changes, new technologies, and best practices for electrical design and installation. Engaging in these activities demonstrates a commitment to excellence and helps ensure that your work meets the highest standards of safety and quality. The discrepancies discussed earlier also highlight the importance of documenting your work thoroughly. Accurate documentation provides a record of the design and installation process, making it easier to troubleshoot problems and verify compliance with the NEC. Documentation should include detailed drawings, specifications, and calculations, as well as records of inspections and tests. This information can be invaluable in resolving disputes and demonstrating due diligence in the event of an incident. Furthermore, proper documentation facilitates communication between different stakeholders in a project, such as engineers, contractors, and inspectors. This ensures that everyone is on the same page and that the project is completed safely and efficiently. In addition to the technical aspects of the NEC, it is also important to understand the legal and regulatory framework in which the code operates. The NEC is typically adopted by state and local jurisdictions, which may also have their own additional requirements. Understanding these local regulations is essential for ensuring compliance with all applicable laws. Electrical professionals should also be aware of their professional responsibilities and ethical obligations. These include a commitment to safety, honesty, and integrity. By upholding these principles, electrical professionals can earn the trust of their clients and colleagues and contribute to the overall success of the industry. In conclusion, the NEC is a comprehensive and essential resource for electrical professionals. By understanding the code, staying up to date with the latest changes, and exercising sound engineering judgment, electrical professionals can ensure the safety and reliability of electrical systems. The discrepancies discussed earlier serve as a reminder of the importance of accuracy, attention to detail, and continuous learning. By embracing these principles, electrical professionals can contribute to a safer and more sustainable future. In practical application, when encountering discrepancies such as those found between the 2002 and 2005 NEC editions, the best practice is to consult with a qualified electrical engineer or a code expert. These professionals possess in-depth knowledge of the NEC and can provide guidance on how to interpret and apply the code in specific situations. They can also help to identify potential conflicts between different code sections and offer solutions that ensure compliance and safety. Furthermore, it is important to remember that the NEC is not a one-size-fits-all document. The code provides minimum requirements, but it is up to the electrical professional to determine the best way to apply these requirements to a specific project. This requires careful consideration of the specific circumstances of the project, including the type of occupancy, the load requirements, and the environmental conditions. In some cases, it may be necessary to exceed the minimum requirements of the NEC in order to ensure the safety and reliability of the electrical system. For example, in a hospital or other critical facility, it may be necessary to install redundant power systems or to use high-quality materials and equipment. Ultimately, the goal of the electrical professional is to design and install an electrical system that is safe, reliable, and efficient. This requires a thorough understanding of the NEC, a commitment to continuous learning, and a dedication to excellence. By embracing these principles, electrical professionals can make a valuable contribution to society and help to ensure the safety of people and property. In addition to understanding the specific requirements of the NEC, it is also important to be familiar with the general principles of electrical safety. These principles include proper grounding, overcurrent protection, and insulation. Grounding is the process of connecting the electrical system to the earth in order to provide a path for fault current to flow back to the source. This helps to prevent electric shock and fire hazards. Overcurrent protection is the use of fuses and circuit breakers to protect the electrical system from overloads and short circuits. Overloads occur when too much current is flowing through a circuit, while short circuits occur when there is a direct connection between two conductors. Insulation is the use of non-conductive materials to prevent current from flowing where it is not intended. This helps to prevent electric shock and fire hazards. By following these general principles of electrical safety, electrical professionals can help to ensure that electrical systems are safe and reliable. And because of the impact on people, it is vital to know that some localities may adopt previous editions of the NEC while others adopt current ones.